Can you hear me good?
Yeah.
Are you having good time?
Yeah. You hear me? Yeah. Great.
This is one of my favorite conference for obvious reasons. Great organizers, great speakers. We have heard some good talks, and all of you. So today we are going to talk about navigating serverless Java applications in the modern DevOps landscape. I'm Monica Tamboli, and I'm with my wonderful colleague.
I'm Daniel Guinan. Dan.
Both of us work for IBM here in RTP, and we work in test organization, testing some of the application server like OpenLiberty and WebSphere Liberty and other products. The reason we are here is our customers are going to write business applications on top of these runtime. So we act as developers where we write different applications, monoliths, microservices. We run them on-prem, Kubernetes, and also we have our own CI/CD pipelines to test those applications. And we also act as operations.
Yep, so I'm mostly in charge on the operations side. We want our environments to be production-like the way our customers would have it. We monitor it with observability, so we have stack with Prometheus, Grafana, Loki, and Stana. Then we also have to handle the updates upon each release. So a lot of work there, and some of the tools we use OpenShift for our Kubernetes, we've got our OCD for GitOps deployment, we use Jenkins and Travis and Ansible to manage our on-prem, and then we use a variety of OSs. So we use the ZOS mainframes, we've got various Linux, PowerPC, and I think we even have some old Spark boxes.
Oh, yeah. The reason we are here is because recently we tested a feature called Liberty Instant On, which expedites Java application startup time, and we will be talking about that as we move forward. So we'll have a foundation for serverless architecture. What are the challenges when we run Java applications as serverless? How do we improve that experience? And then we will focus on serverless on Kubernetes and followed by a demo. Again, we don't claim ourselves to be experts on this field with the fast changing, rapidly changing technology, but we are here to show what we know, and we will be willing to know if you are doing work in this technology. We would love to hear your experience with any of these technologies. So we'll start here. Cloud native technologies are on the rise, right, for the benefits it provides. What means by cloud native technologies is that your applications are really taking advantages of all the cloud features it provides. So there are many benefits of having your applications on cloud. Some of them is agility, right? So in earlier times, you had to start with your infrastructure, right? Then put OS, then install other dependencies. With cloud native, you can have SaaS, you can have software as a service, infrastructure as a service. You can start really quickly. Scalability, you can start small and increase as your needs change. Cost optimization is a big one where you only pay for what you use. And it also allows you to have redundancy where you can have your application across different zones, regions, things like that. And some of the key technologies in cloud is microservices functions where you decompose your application into really small, loosely coupled services which can be deployed and scaled independently. Also containerization, it reminds me of the shipping containers where you bundle all your dependencies with your application. And when you have containers, you want to think about how are you going to manage those containers. You need to manage networking, scaling, all those things, and that's where Kubernetes comes into picture. And also CI/CD, you want to make sure your application integration and delivery is automated. And another important aspect of cloud native key technology which is coming up is serverless. We had a talk earlier on as well on serverless. So let's see what serverless means here. So what do you think, Dan? Does serverless means we don't need a server?
It sounds like it.
I wish it was the case. It's not that case that we don't have a server. It just means as a developer, you don't need to worry about the server. So cloud provider will manage the infrastructure for you. So you don't have to worry about, putting patches and all those things on the server. So some of the characteristics of the serverless is you can scale up and down on demand. Another important aspect is scale down to zero. Yes, you can scale up and down, but what about when there is no traffic? Can you scale down to zero and have no cost at all? Then you pay for only the compute resources you are using. So if there is no traffic, then it scales down to zero. You don't have to pay for when you're not using it, the resources. I hit too quickly. Stateless. So stateless is very important aspect in serverless. Actually, it reminds me of you all have seen Finding Nemo movie. You remember Bluefish Dory? She had acute short-term memory loss, right? She did not remember like what happened earlier on. So serverless is like that. Like you just run it. You don't need to remember what happened earlier. So in this space, you also want to reap all the benefits. You want to have microservices or functions where it has small services. So for serverless, most of the cloud providers provide some way of writing function as a service, being able to run in serverless mode. And also serverless makes sense in terms of Kubernetes also. Here Kubernetes clusters could be on one of these cloud providers, or it could be running on-prem. And there are choices. If you're running serverless on Kubernetes, there are choices. And one of these choices we are going to talk about today is Knative in our demo as well. So we have talked about that cloud providers have a way to scale up and down, even scale to zero. First thing you need to think about is the application, right? Is your application ready to be run as serverless? So what do you think is the most important thing if you're running something serverless?
I mean, if we're scaling from zero, we're going to need to start like that.
So the startup time, right?
Yep.
The next question is, like, what about Java applications? Do you think they are ready for serverless? Maybe before we answer that question, let's see, let's Java 101, you remember all these? Java was created like more than 25 years ago, 95? Yes. I was just starting my college at that time.
I was still on diapers.
Yeah. So here on the left, if you see, you take your Java application, you compile it. During the build time, you compile it to bytecode. And then whenever you're ready to run it, you take the bytecode and then there is an interpreter if you can read, and that will convert it into the machine code. The problem here is, although that makes it machine independent, it makes it portable, interpreters are known to be slow in nature. So that causes Java applications to start slow. But at the same time, they are great at, if you keep on running your application, it increases throughput, especially because Java over time became more optimized with JIT. If you see JIT, just-in-time compiler. So what it allows you to do is, if some of the code is being called repeatedly, then it's going to compile it instead of doing interpretation. So that makes it faster over time. But we still have the problem that it's slow to start up. So what do you think?
I'm going to have to stop there, Monica. I mean, it's going to be controversial, but Java wasn't made for the cloud.
Right.
It was made, like you said, 25 years ago. And for serverless, I just don't see a way we can get past the startup time.
So the thing is, in that case, do you think we should just abandon Java and start using something else like Python, Go, and other things?
Well, this goes back to the benefits of Java. I mean, JIT and JVM are great, like you said. We get the long running efficiency. It's been proven over 25 years, and we go with the benefits of Java. There's great open source communities, great libraries, documentation, and obviously we have a lot of investment in it, and so do many companies. So it's not easy just to switch like that.
Exactly. We have companies who are, invested in this. They want to keep on using this technology, and they have probably already invested in cloud. So they have reasons to keep on using this and make the benefit of something which has survived for so long.
I just don't see how we can run in serverless, is the thing.
Yes. So to answer this question, over time, there has been new improvements to Java which makes it relevant to be started quickly, for Java applications to be started quickly. And we are going to talk about such two technologies. One is ahead of time compilation, GraalVM. Has anyone heard about Graal? Okay, a few people. So it makes use, GraalVM makes use of AOT. And the second one is checkpoint restore in user space. And we are going to show one demo using Cryo. Anybody heard about Cryo? All right. One. All right, we have one. Yeah, I think if you can just take away the main point, how they are different, that would be good in case you want to use any of these technologies. So coming to the first one, ahead of time. So earlier, in our Java 101, we saw that we generally first convert our application to bytecode and then to machine code. And JVM runs interpreter from bytecode to machine code. In this case, if you see the second one, so you are creating native executable during your compile. You just compile it to native executable, and then when you are ready to execute, you don't need JVM. So this will increase the startup time for your application, make it really quick. But so it's great for those short-lived applications like start, quickly done. But it loses some of the advantages of what you wanted Java for. So you don't have portability anymore because you are creating applications into your native code for your OS. So that's where we come to the other option, which is checkpoint restore. This is an open source Linux project, can be used on any Linux process, and one of the aim is to improve the startup time for applications. The way it works is, it lets you take a snapshot of your running application, and then when you are ready to restore it, deploy it, you restart from there. So you don't have to restart your application from the ground up. So you can start from somewhere where you took the checkpoint. And what we are going to show is, we work on one of the product called Open Liberty Runtime. So this is the implementation example of using Cryo. So very quickly, Open Liberty is a lightweight Java runtime for building cloud-native enterprise applications. It's flexible. You only use the features which your application is going to need. Zero migration. It's great for Kubernetes and containers because it's very lightweight. And it also has operator which we can use to deploy the applications. So just to sum up how this works is on the right. For your application to make use of that feature, instant feature for quick startup, you are using the Liberty Instant On feature, which actually uses Semeru JDK, which also has that feature. And Semeru JDK uses Eclipse OpenJ9 JVM, which is based on Linux Cryo feature, which we just talked about. So what this enables is that your application, which typically took seconds, I thought you were going to say minutes, but yeah, let's say seconds.
I mean,
it's to milliseconds, depending, and it can be up to 10 to 18 times faster. You are still keeping all the benefits of your JVM, garbage collector, right? Because it has been optimized over a long period of time, JIT optimization. Also, you have the same image between your development and production. So let's talk a little bit about checkpoint. We talked about snapshot, right? How it works. So you would want to read this like from bottom up. So as your application is starting up, first it will load the kernel. Then it will start getting ready with loading the features it needs. So you can take checkpoint just before your application code is being executed. Or you could take checkpoint after application has started. So if you take snapshot later, you can automatically think like it will start quicker because now it has to just restart from the later point. But the point here is there might be some reasons why you may want to take checkpoint before application starts in case your application start up is doing things like connecting to some remote database. So there might be some challenges you need to think about where exactly you want to take checkpoint. But to reap the most benefits of quick startup, you want to take it after app start. So this is how you take checkpoint. So this is a typical container file. The first, if you see, we are starting with our Liberty container with a specific Java. You copy your application file. You see a copy command, it might be hard to read. And then the important thing is we are running this utility run checkpoint, and we are passing it where to take the checkpoint. So in this case, we are taking the checkpoint after app starts. So at that time, it will add a layer of your checkpoint to your container image. So then you push this container image to your image registry, how you have been doing earlier.
And keep in mind the checkpoint script is in the image.
Right, checkpoint is in the image which we are doing starting from.
Base, yeah.
Yes. So this is just recap of what we have talked so far. On the left, during build time of your application, now as you are creating container image, you have taken a checkpoint of your application. During the checkpoint we talked earlier, it starts the application, takes the checkpoint, and then kill the application. So it has that information stored as part of the snapshot. So now when you're ready to run this application, deploy it, let's say you're deploying it to Kubernetes, OpenShift, wherever, it's going to, instead of using your previous image which you used for your application, now you are going to use your checkpointed image, the image which has the layer of checkpoint in it. And if you have multiple pods, all of them are going to start from that point on. So it makes your application start pretty quickly. So what do you think?
Okay, I see your point. I'll give it a shot. So here we have pretty monolithic app. Starts up pretty quickly without instant on. Liberty starts up fairly quickly for Java, but 15.077 seconds. If we're trying to start that from 0, that's just not going to cut it. Now, after taking the checkpoint, however, with instant on, 0.415 seconds, it's ready for traffic. I think we can work with that. And it's also as fast as Guinan. I have a source for that, for those wondering. So like Monica said before, we're focusing on serverless on Kubernetes. And the benefits of serverless on Kubernetes is you're freeing up your cluster resources. Instead of having those servers always running, you just have it running when you need it. It also lowers power usage because you're reacting in real time, and it's less constrained than SaaS offerings. It's your cluster, you make the rules. And we're also focusing on Knative for this. There's other options, but we just went with this one. It's platform agnostic, and that's in the sense that any Kubernetes cluster will work on. It's open source, because who doesn't love that? And then you can find more at knative.dev. So the key features of it is the Knative serving, which pretty much runs and controls the serverless workloads. Knative eventing, which lets you focus on the eventing aspects, as well as the newer Knative functions, which is a programmatic way where you type a command and then you run your serverless workload, allowing your developers to not have to know Kubernetes, Docker, or really anything, just a simple command. Now, how does it work? This chart is very complex, so I like to simplify it down to this. So from 0, traffic for a Knative service comes in. The Knative service sees that traffic and then posts the service as currently scaled to 0. It says, hey, time to wake up, there's traffic. And it wakes up, traffic's then forwarded to that service. And then eventually to 0, once the traffic ceases, Knative service says, okay, back to sleep, and then shuts down. So, like that chart showed, there was a lot more going on, but it can be simply understood like that. Now, a Knative service is slightly different than the Kubernetes ones. You create your Knative service, which manages both the route as well as the configuration, and it creates revisions, which are essentially pods. Now, the key benefit is scale to 0. It's able to achieve this using its own Knative pod autoscaler instead of the default horizontal pod autoscaler in Kubernetes. You have versatility, like I said before, your cluster, your rules, you decide how it works, and it's platform agnostic. So if you move providers or go on-prem or whatever, you can take it with you. Now, it's pretty easy to get started with Knative. First, you just have to install the operator, which in our case, we're Red Hat and OpenShift. We just used Operator Hub, but you just use Helm chart or you just apply the deployments. You then create a Knative serving instance. There's great guides on how to do that, but it's just a single CRD object. And then you're good to create Knative services. Now for our demo, we're going to focus on one of our microservice applications running 5 Open Liberty applications. It's a fictitious airline, and we're going to turn one of the microservices to serverless.
Give it a try. Live demo.
Yeah, fingers crossed. No. Okay, so here's how the app looks. It's a little airline. You log in, you can see your flights, so on. Now, let's take a look at the pods. So you'll see here we have 5 pods running, one for each microservice. And here we have this standard startup. So there's no instant on here. This is just running as is. And it looks like, so default server rate runs Smarter Planet. That's Liberty start message. It's probably hard to read, but trust me on this. It says 9.270 seconds, which fast, but not serverless fast. We were able to deploy these using the Open Liberty operator, which also easy to install. We again did just the operator hub, but you can install via customized Helm chart, very easy to install. Now, let's change one of our services, the booking service, to be using instant on.
So now you're using that image we created during checkpoint.
Yes.
Instead of using the regular image.
Yep. So since all we're creating is an image, all we have to do is just go in here, edit once slow. We just have to go in here, add the application image and the spec. So say we had it to, the tag is instead of whatever we had it as, it's checkpoint. Now we would save. And then we're set with our checkpoint image. I already have it deployed here, just to not keep your time. Okay, here we go. So this one started in 0.409 seconds. So
seconds to
milliseconds, yeah. So this is something we can work with for serverless. Now, since it's just a container file, this is still always running. It's not serverless at this point.
It's not scaled to 0, it will still scale up.
Yep. It'll still scale up, scale back down to 1, and you get all the benefits of the JVM. So if you want, you could just use this image for your long-running actions because it has JIT and GC. So, so now to make it Knative, the Open Liberty operator makes it very easy for us. all we have to do is just go in here. So we have our booking service, we edit, and they make it that it's just a flag. So create Knative service, true. And then as long as we have that image, we're all set to go. Now a little on Knative. The install, like I mentioned, we did it through the operator hub, and it's called here Red Hat Serverless because Red Hat. But pretty much you just create your Knative serving here. It's required in the Knative serving namespace. They kind of give you default ones that you can use, so it's easy to get started with it. And I showed that very, very complex graph. Once you create the Knative serving instance, it does have all of that running in the back end, but for our purposes, it just matters that it works. Now let's go back to the pod counts. We should see this one. Okay, currently it is still scaled up. However, we can scale it down to 0. Oh, no, there it is, terminating.
So at this point, you enabled Knative so that since there is no traffic to that particular service, so it's going down, scaling down to 0.
Yeah, and it seems like it's just a quirk that when you create the Knative service, it starts up at. And
then it's going down, detecting like nothing.
Yeah.
It doesn't need to serve anything. Let's take a rest.
Yeah. Yeah, there we go. So now we're back down to 4. And let's go to back to the application. So here, when we go to configure, it makes a call to all the microservices, just getting what's your status. So here, booking slightly slow. There it is. So slightly slower than the others, but definitely doable. And you see back here, scales up. And then we can go to log, see it started up. Now, with this, you can see when it scales down that the memory usage here is gone. So you can use that wherever else you want. You don't have to worry about upgrading your cluster. You get the most out of your resources. And say we were to take it a step further and make 3 of the microservices serverless. In that case, I mean, we're only using consistently, what is this, 300, 350 megabytes of RAM?
So, yeah, depending on what.
Right, yeah. So you get the most out of your resources with that. Okay. So just a recap of it, with Instant On, we could make our microservice serverless ready. You really couldn't tell that it scaled from 0. It was happening pretty quick. Knative is very versatile. There's a lot of config options, a lot of things you can do with it. And serverless workloads, you saw the memory usage decrease. There's some challenges with it. Getting your app ready could be difficult. That startup time with Java can be tricky, but with Instant On, we just had to add a step to our Docker file and our CI/CD pipeline, and we're good to go. You shouldn't make everything serverless. That's a design decision that you would have to make. I know when I first started, I'm like, oh, let's make everything serverless. And then had an issue where a pod would shut down before it would receive a call, and it would just break everything. So you have to decide what you want serverless and what you don't want to be. Creating serverless resources can be a bit complicated. It's its own custom resource, but with the open delivery operator, we just have to set a flag to true, so it's pretty easy there. And then, like I said before, your cluster, your rules, that also means you have to design your architecture. You aren't being provided one by a cloud provider, so that's freedom, but you have to make it yourself.
So we'll wrap up our session by just summarizing that serverless is promising for rapidly bringing new functions to market. It can reduce operational costs, as we saw. But as Dan mentioned, not all applications are appropriate for serverless, especially applications which need to be up for most of the time. It does not make sense to make them serverless. And Java applications can be used as serverless if you use the right technology, and Liberty Instant On is a great choice.
So the question now is not, can I run my Java application serverless? It's now, should I?
Yes. So at this point, we would ask you to give it a try if you are someone using Java applications. Give it a try. Think about if you should use it or not. And here are some of the resources if you want to get started with any of the things we talked about. Feel free to give it a try. There are guides there. And if you decide to connect with us, feel free to take a picture.
We'll be here all day.
Yes, and we would love to hear from you if you are using any of these technologies. Right on time.
Awesome.